Hey guys, good evening and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So my dear students, can you quickly let me know in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you? Let me know quickly in the chats. Let me know quickly in the chats if all of you can hear me, if I'm perfectly audible, visible to every one of you. Good evening, people. Good evening, and welcome back. So, my dear students, as I told you, today we'll be discussing some more important concepts, the short concepts, which are going to be asked in the NEET 2026 examination from the subject chemistry. And today, yes, we are going to do some very important concepts. I would say whatever concepts I'll be discussing with you in the today's session, right? More than 90% chances are there that they'll come in your NEET 2026 examination for sure. Happy birthday, sir. Happy birthday, sir. Happy birthday, sir. Thank you so much. Thank you so much. Thank you, everyone. Thank you. Yes, it's my birthday today. 6th of April. Yes, it's my birthday today. So where is my gift? Yeah? So where is my gift? Where is my gift? Is it on the way? Is it on the way? Thank you everyone. Thank you. Thank you so much. Thank you so much. Thank you so much, guys. Just give me a second. Just give me a second. Perfect. Perfect. Exactly. Your selection is going to be my birthday gift. That's an amazing answer. Absolutely. Right? That's going to be the best gift ever. Yeah, that's going to be the best gift ever, people. Honestly. Yeah, honestly. So after writing the NEET examination, yeah, when you do amazing in the NEET examination, then I should be the first one who you'll be texting. Yes, we have made it. And I'll be waiting for that day. I'll be waiting for that day. I will be waiting for that day. Yes. All right. So should we start, people? Should we start? All right, people. Perfect. Let's get going. Let's get started. Right? So till now, as far as I remember, we have discussed almost like 15, 17 concepts, right, in the earlier sessions. So today we'll be discussing more concepts, more important concepts, which are going to be asked in your NEET 2026 examination for sure. And I'm not going to like go into very detail. No, I'll be discussing only those parameters by means of which you'll be able to solve the questions, right? That's more than sufficient for you. I'll be discussing that stuff by means of which you'll be able to solve the questions. Nothing more, nothing less. All right? Perfect. Chalo then. Let's get going. Let's get started. And my dear students, let's start the session with which concept? Wait, let's start the session with the concept of balancing of redox reactions. Balancing of redox reactions. A frequently asked question. How do we exactly balance the redox reactions? My dear students, one simple method I'm going to give you. The method which I'm going to give you, by means of that, you can easily balance the reactions for sure. Okay, so let's have a look what method I'm talking about. My dear students, I am talking about the method that's called as the oxidation number method. the oxidation number method. And this oxidation number method, first of all, it is used to balance the redox reactions. And today we'll be discussing this oxidation number method first in acidic medium. First we'll be discussing this in acidic medium, and then we'll be discussing the same method in basic medium. So technically, I'm going to show you how to balance the redox reactions in acidic medium and basic medium. This is our first concept of the today's session. So people, without wasting any sort of time, let's get going, let's get started, and let me take an example over here. So first of all, let's see how do we balance the reactions in acidic medium. Let's see how do we balance the reactions in acidic medium. Acidic medium. Okay. For example, I am going to take a reaction like this. MnO4 negative plus Fe di positive. For example, it gets converted into Fe tri positive, and with that you have got Mn di positive. Let's say this particular reaction I'm supposed to balance in acidic medium. So how do I balance this reaction? Have a look. Have a look properly what I'll be doing. My dear students, first of all, if I ask you what is the oxidation state of manganese here, you should be knowing how to calculate the oxidation state. Let the oxidation state of manganese be X plus. Oxygen shows -2 oxidation state. There are 4 oxygen atoms. Net charge here is -1. So when you solve this, the value of X comes out to be +7. So I would say this manganese here is in +7 oxidation state. Number 1. What is the oxidation state of this iron over here? It is simply +2, as you can see. Oxidation state of iron here, it is +3, as you can see. Oxidation state of manganese here, it is +2, as you can see. So I calculated the oxidation states first. Now, my dear students, do one thing. The oxidation state of manganese is going from +7 to +2. Oxidation state of manganese is changing from +7 to +2. So +7 is the initial oxidation state of manganese, and this +2 is the final oxidation state of manganese. So I am asking you to calculate the change in the oxidation state of manganese. I'm asking you to calculate the change in the oxidation state of manganese, which will be final oxidation state of manganese minus initial oxidation state of manganese. The value comes out to be 5. Final oxidation state of manganese minus initial, the value comes out to be 5. 5 is the change in the oxidation state for one atom of manganese, and over here I have only one. So I would say the N factor of this MnO4 negative is 5. How did I calculate its N factor? Final oxidation state minus initial oxidation state. That comes out to be 5, right? 5 is the change for one atom of manganese. I've got only one. So 5 into 1 is 5 only. Point number 1. Similarly, +2 to +3. +2 to +3. What is the change? Final minus initial. The value comes out to be 1. 1 is the change for one atom. I have one atom only. So its N factor is 1. So my first step always is going to be to calculate the N factors of reactants. This is my first step always. After calculating the N factor, my dear students, I'm supposed to crisscross these N factors. I'm supposed to crisscross these N factors. What does that mean? That means this 1 will go here and this 5 will go here. Crisscross. Simple. After crisscrossing the N factors, balance all the atoms except hydrogen and oxygen. Balance all the atoms except hydrogen and oxygen by hit and trial. By hit and trial. Yeah? Right? So my next step is balance all the atoms except hydrogen oxygen. So first of all, do you see there is one manganese? Yes. So on this side there should be one manganese. Do you see there are 5 iron atoms? So on this side there should be 5 iron atoms. So I have balanced all the atoms except hydrogen oxygen. Now after this I am supposed to balance oxygen with the help of water molecules. How exactly? Have a look. On left side, do you see any oxygen? Yes, I can see 4 oxygen atoms on left side. On right side, is there any oxygen? No. So which side is oxygen deficient? Right side. How many oxygen deficiencies are here? 4. So on this side, simply add 4 water molecules. Add 4 water molecules. And after balancing oxygen, I'm supposed to balance hydrogen with the help of H positives. How exactly? Do you see any hydrogen on this side? No. Do you see any hydrogen on this side? Yes. How many? 8. So do you see this side is hydrogen deficient? Yes. How many hydrogen deficiencies? 8. So just do one thing, add 8 H positives on this side. The reaction is balanced. The reaction is balanced. Did you understand? Did you understand, people? Let me take one more example in this acidic medium. Let me take one more example. With that, things will be more clear. Is this method easy? First of all, calculate the N factors of reactants. Number 2, crisscross the N factors. Number 3, balance all the atoms except hydrogen oxygen. Number 4, balance oxygen with the help of water. At the end, balance hydrogen with the help of H positives. That's all. Nothing more, nothing less. Yeah? Now, people, let me take one more example. With that, things will be more clear. For example, I'm taking the reaction like this. Cr2O7 di negative plus Sn di positive. For example, it gives Sn plus 4 plus Cr tri positive. Again, I have to balance this reaction. In which medium? In acidic medium, right? My dear students, what is my first thing? What is my first thing? What is my first thing? Have a look. First of all, calculate the oxidation state of chromium. This will be 2x minus 2 into 7 is equal to minus 2. So the value of x comes out to be plus 6. This tin is already in plus 2 oxidation state. Here, tin is also in plus 4 oxidation state. Here, chromium is in plus 3 oxidation state. Do you see one thing? Plus 6 to plus 3. Chromium is going from plus 6 to plus 3. What is the change? Final minus initial. The value comes out to be 3. 3 is the change for one atom of chromium. I have 2. So 3 into 2 is 6. 3 is the change for one atom of chromium. But I have 2. So 3 2s are 6. Right? Right, people? Now, what about the N factor of this one? Have a look. Initial oxidation state of tin is plus 2. Plus 2 to plus 4. Plus 2 to plus 4. What is the change? Final minus initial. The value comes out to be 2. 2 is the change for one atom. I have only one. So its N factor is 2. So I got the N factors. I got the N factors of reactants. After getting the N factors of reactants, just crisscross them. So this 2 goes here. This 6 goes here. Now, balance all the atoms except hydrogen oxygen. So 4 chromium here, 4 chromium here, 6 tin here, 6 tin here. Right? Now balance oxygen with the help of water molecules. Do you see any oxygen on this side? Yes, I can see. 7 2s are 14. 14 oxygen atoms on this side. Any oxygen on this side? No. So which side is oxygen deficient? Right side. How many oxygen deficiencies? 14. So add 14 water molecules on this side. Okay. Now, it is the turn for hydrogen. Do you see any hydrogen on this side? No. Do you see any hydrogen on this side? Yes. How many? 28. So which side is hydrogen deficient? Which side is hydrogen deficient? This side is hydrogen deficient. How many hydrogen deficiencies? 28 hydrogen deficiencies. So add 28 H positives on this side. The reaction is balanced. Done? Done, people? Did you understand how do we deal with such kind of the questions? Quick in the chats. I'll take one more example. With that, things will be more clear. Yeah? See, the method which I'm showing you, you're not supposed to balance the charge here. The charge automatically gets balanced in acidic medium. Don't worry. I'll take one more example. With that, things will be more clear. For example, you have got the reaction like this. Let's say you have got Cr2O7 di negative plus C2O4 di negative. Let's say it gives carbon dioxide, and with carbon dioxide, we got Cr tri positive. Correct? What is the first thing? Get the oxidation states. Oxidation state of this chromium, you should remember it by now. It's plus 6. What about the oxidation state of this carbon? This will be 2x. Oxygen will show minus 2 into 4 is equal to minus 2. So this will show plus 3. This carbon, x minus 2 into 2 is equal to 0. So plus 4. And this is already in plus 3 oxidation state. Now, plus 6 to plus 3. Chromium is going from plus 6 to plus 3. What is the change? Plus 6 to plus 3. What is the change? Final minus initial. The value is 3. 3 is the change for one atom. 2. So 3 2s are 6. Its N factor is 6. Right? Now, plus 3 to plus 4. Plus 3 to plus 4. What is the change? 1. 1 is the change for one atom. 2. So its N factor is 1 into 2, 2. Got the N factors? Now, after getting the N factors, crisscross them. Crisscross them, people. This 2 will go here. This 6 will go here. After crisscrossing them, after crisscrossing the N factors, now balance all the atoms except hydrogen oxygen. So you have got 4 chromium on this side, 4 chromium on this side, 12 carbon atoms on this side. So 12 carbon atoms on this side. Now it is the turn for oxygen. How many oxygen atoms do you see on this side? 7 2s are 14 plus 6 4s are 24. So you have got 38 oxygen atoms on left side. What about right side? 12 2s are 24. Only 24 oxygen atoms on right side. So if I ask you, which side is oxygen deficient? Right side is oxygen deficient. How many oxygen deficiencies? How many oxygen deficiencies? On this side, 38. On this side, 24. I'll say 14 oxygen deficiencies on this side. So simply add 14 water molecules on this side. Which side is oxygen deficient? Right? Now, my dear students, balance hydrogen with the help of H positives. No hydrogen on this side. On this side, 14 to 28 hydrogens. So left side is hydrogen deficient. How many hydrogen deficiencies? 28. So add 28 H positives on this side. So the reaction is now balanced. You need not to check it. Say yes or no in the chats if you got it. Everyone. Is it clear? Is it clear? Quickly in the chats. Everybody. Everybody in the chats. Is it clear? Is it clear, my dear students? Quick. Perfect. Okay. Perfectly done, guys. Now let's see how do we balance the redox reactions in basic medium. How do we balance the reactions in basic medium? My dear students, in basic medium, the things are almost similar. The things are almost similar in basic medium. Okay? In basic medium, things are almost similar. First of all, the first step is same. What is my first step? First step is get the n factors of reactants. Get the n factors of reactants. Second point, crisscross the n factors. Third point, balance all the atoms except hydrogen, oxygen. Now comes a change. Balance the negative charge with the help of OH negative ions. And after that, balance oxygen with the help of water molecules. You are not supposed to balance hydrogen here. Hydrogen automatically would have got balanced. Hydrogen automatically would have got balanced. Right? Right, people? Okay. Now let's have a look. I'm going to take one example. For example, the reaction I'm taking is that is Cl2 plus IO3 negative. It gives Cl negative plus IO4 negative. For example, this is the reaction. I need to balance this particular reaction. I need to balance this particular reaction. Try to understand what I'll be doing. Try to understand carefully what I'll be doing. My dear students, have a look properly. Oxidation state of chlorine here is 0. When it comes to iodine, x minus 2 into 3 is equal to minus 1. So x value is coming out to be plus 5. This chloride will show minus 1 oxidation state. This iodine here, when you calculate, it will be plus 7. Now, 0 to minus 1. 0 to minus 1. Change is 1. 1 is the change for one atom. I have 2. So its n factor is 2. Plus 5 to plus 7. Plus 5 to plus 7. Change is 2. 2 is the change for one iodine. I have only 1. So its n factor is also 2. So I got the n factors. After getting the n factors, what am I supposed to do? After getting the n factors, people, what am I supposed to do? Crisscross them. So this 2 will go here. This 2 will go here. Well, after crisscrossing the n factors, balance all the atoms except hydrogen, oxygen. So 4 chlorine on this side. So 4 chlorine on this side. 2 iodine on this side. So 2 iodine on this side. So I'm done till here. I am done till here. Now, my dear students. Now, my dear students, balance the negative charge with the help of OH negatives. Balance the negative charge with the help of OH negatives. Right? Have a look how. Do you see any charge on chlorine? No. The charge present on this IO3 is minus 1. So one IO3 molecule carries minus 1 charge. 2 IO3 molecules will carry minus 2 charge. Cl carries minus 1. So 4 Cl will carry minus 4. 1 IO4 molecule carries minus 1. 2 IO4 molecules carries minus 2. So on left side, the charge is minus 2. On right side, the charge is minus 6. So which side is negative charge deficient? This side is negative charge deficient. How many negative charge deficiencies? 4. So simply add 4 OH negatives on that side, which is negative charge deficient. Now after this, balance oxygen with the help of water. So how many oxygens do you see here? 3 2s are 6. 6 plus 4, 10. So 10 oxygen atoms on this side. 4 2s are 8. 8 oxygen atoms on this side. Which side is oxygen deficient? Right side. How many oxygen deficiencies? 2. So add 2 water molecules here. Now the reaction is balanced. You need not to check it. It's a balanced chemical equation. Did you understand, people? Did you understand? Everybody in the chats, quick. Quickly, people, quickly. Everyone in the chats. Yes or no in the chats, quick. It will be mentioned in the question whether the reaction is happening in the acidic medium or basic medium. All right. Should we move on? Should we move on to the next topic, people? Guys, you can do one more thing here. You can see all the stoichiometric coefficients are even numbers, right? So you can divide throughout with 2. When you divide throughout with 2, this becomes 1, this becomes 1, this becomes 2, this becomes 2, this becomes 1, this becomes 1. You can do that too. Yeah? One example here I'm giving you as a homework. Do give it a try on your own with the help of same method. The reaction is MnO4 negative plus Br negative. It gives MnO2, and with MnO2 you got BrO3 negative as well. This example is in your NCERT as well. Okay. Do balance this particular reaction in basic medium. Do give it a try afterwards. Okay. Be careful with the n factors here. This is oxidation state, here is -1. Here the oxidation state is +5. So final minus initial. Final minus initial. Final is +5 minus initial is -1. So this is 6. So its n factor will be 6 basically. So that's why give it a try properly. Okay. Or should I solve this? Should I solve this on my own? Let me solve this on my own. Okay. It's okay. Let me solve this on my own. Have a look, people. Have a look. So first of all, oxidation state of manganese here. When you calculate, it's +7. Bromine here is in -1 oxidation state. Manganese here will be in +4 oxidation state because this is X -2 into 2 is equal to 0. So +4. And this bromine here will be in +5 oxidation state. Now, +7 to +4. +7 to +4. Changes 3. 3 is the change for one atom. I have only one. So its n factor is 3. -1 to +5. Changes 6. 6 is the change for one atom. I have only one only. So this 6 goes here. This 3 goes here. Right? So I'm done till here. Now, balance all the atoms except hydrogen, oxygen. Balance all the atoms except hydrogen, oxygen. So 6 manganese on this side, 6 manganese on this side, 3 bromine on this side, 3 bromine on this side. Now, balance the negative charge. On one MnO4 molecule, the charge is -1. On 6, the charge will be -6. On one Br, charge is -1. On 3, the charge will be -3. So -6 -3 will be -9. The charge on this is nothing. The charge on this molecule is -1. So on 3 molecules, it will be -3. So which side is negative charge deficient? This side. How many negative charge deficiencies? 6. So add 6 OH negatives on this side. Add 6 OH negatives on this side. Now, balance oxygen with the help of water. So 6 4s are 24. 24 oxygen as atoms on this side. On this side, how many? 6 2s are 12 plus 3 into 3 is 9 plus 6. 9 6 is 15. 15 plus 2 is 15 plus 12 is 27. So 27 oxygen atoms on this side, 24 oxygen atoms on this side. Which side is oxygen deficient? Left side. How many oxygen deficiencies? 3. So add 3 water molecules on this side. Now the reaction is balanced. You need not to check it. Understood? Everyone understood? Understood, people? Everyone in the chats? This was your one important concept which is frequently asked when it comes to your NEET examination. Okay? Now, my dear students, there is one more concept that is frequently asked. What is that? That is the concept from thermodynamics. Almost every year. If not every year, alternate years, question will be asked from this particular concept. That will be criteria for spontaneity. Have you seen those questions wherein they mention calculate the temperature above which or below which the process is spontaneous? Have you seen them? Calculate the temperature above which or below which a process will be spontaneous. Calculate the temperature at which the process will be at equilibrium. Have you seen those questions in thermodynamics? Yes or no? Have you seen them? How do we deal with such kind of the questions? Let's have a look. My dear students, first of all, which I believe every one of you would be knowing, how do you calculate delta G? There's a formula to calculate delta G. Delta G is equal to delta H minus T delta S. Delta G is Gibbs free energy change. This is enthalpy change. This is entropy change. This is T stands for temperature. This is your relation between delta G, delta H and delta S. Delta G is equal to delta H minus T delta S, right? Delta G is equal to delta H minus T delta S. Sir, do you know Tamil? Well, I can understand Tamil. I have started my teaching career from Chennai only. Okay? My college was in Chennai. I have studied in Chennai for 5 years. Yeah. Okay, so I can understand. What do we say? Tamil kuncham kunjam terima, something. Yeah? I hope I'm right. Was I right with this? Yeah. I still have like one very close friend of mine there in Chennai. Do you know Shimon? Shimon Joseph? Shimon and me, we have started the teaching career together from Chennai only in offline mode. He was from IIT Madras. You would have seen his classes. He teaches 9, 10 standard students, like all the subjects. Okay. Chalo, let's move on now. Let's move on. Let's move on. Let's move on. Let's move on. All right. Have a look in people now. So first of all, you know delta G is nothing but delta G is equal to delta H minus T delta S. Delta G is equal to delta H minus T delta S, right? Now, there are three things which you need to remember. My dear students, whenever delta G for the system, at constant pressure temperature, whenever delta G for the system at constant, remember it as such, whenever delta G for the system at constant pressure temperature comes out to be negative, we say the process is spontaneous. We say the process is spontaneous. Whenever delta G for the system at constant pressure temperature comes out to be positive, we say the process is non-spontaneous. We see the process non-spontaneous. And whenever you see delta G for the system at constant pressure temperature equal to 0, we say the process is reversible. Or you can say system surroundings are at equilibrium. These are three things, first of all, which you should remember. Whenever a question is asked, calculate the temperature above which or below which the process is spontaneous, right? These are the three conditions which you have to remember. And my dear students, how do we deal with such conditions? How do we apply them in the questions? Try to understand what exactly I'm going to say. Try to understand very carefully. For example, this is the question. This is the JEE Mains PYQ as well. This was asked in JEE Mains. Look at the question carefully. Look at the question carefully, guys. First of all, you are given with the reaction A gives B. Its delta H is given. Its delta S is given. We have to calculate the temperature above or below which the process is spontaneous. Now you tell me, for the process to be spontaneous, we know delta G should be negative. For the process to be spontaneous, we know delta G should be negative. Now delta G should be negative. That means delta H minus T delta S should be negative. Right? Now first of all, do you see delta H in kilojoules and delta S in joules? So convert this in joules. 80 kilojoules means 80,000 joules. Right? So delta H is nothing but it is 80,000. 80,000 minus T is the temperature. Delta S is given to me as 2 times T. 2 times T. So delta S is 2 times T. 2 times T into T makes it 2T square. Right? This should be less than 0. If I take 2T square on that side, I can say 80,000 is less than 2T square. If I take the reciprocal, if I reverse stuff, I will say 2T square should be greater than 80,000. 2T square should be greater than 80,000. That means T square should be greater than 40,000. Divide by 2, right? T square should be greater than 40,000. It means T should be greater than root of 40,000. Root of 40,000 is 200 Kelvin. So what does it mean? It means temperature should be kept greater than 200 Kelvin. Temperature should be kept greater than 200 Kelvin. Then only this particular reaction will be spontaneous. Understood? Temperature should be kept greater than 200 Kelvin. Then only this particular reaction will be spontaneous. So this particular reaction will be spontaneous at temperature greater than 200 Kelvin. Right? the reaction will be non-spontaneous at temperature less than 200 Kelvin. And reaction will be at equilibrium at temperature equal to 200 Kelvin. So anything can be asked. Anything can be asked. Anything can be asked. Right? Right, people? I believe this is clear to everyone. If yes, let me know once in the chats. Quickly. Quickly, people. Done? Okay, one more question I'm giving you. This is also the asked question. This is also the asked question. This is also a PYQ of your JEE mains. My dear students, if you look carefully, you are given with a reaction. Entropy. S represents entropy. S represents entropy. Entropy of all the reactants and products is given. Entropy of all the reactants and products is given. Entropy of all the reactants products is given. Delta H for the reaction is also given. Now, the question is asking, what exactly? Calculate the temperature above which the process is spontaneous. Calculate the temperature above which the process is spontaneous. Now, have a look how I'm going to deal with this question. Since we are given with entropy of all the reactants and products, first of all, remember one thing. Entropy change during the reaction, delta S. I'm given with entropies of all the reactants and products. I'm given with entropies. First of all, I have to check the temperature above which the process is spontaneous. Well, for the process to be spontaneous, delta G should be negative. Delta G is nothing. That is delta H minus T delta S. This should be negative, right? This should be negative. It means that delta H should be less than T delta S. If I reverse it, I can say T delta S should be greater than delta H. Or I can say temperature should be greater than delta H by delta S. Temperature should be greater than delta H by delta S. Now, people, we are given with delta H in the question, but delta S, entropy change of the reaction, is not given. So, I'm supposed to calculate entropy change of the reaction. I am supposed to calculate entropy change of the reaction. How exactly? It's simply going to be entropy of products minus entropy of reactants. Entropy of products minus entropy of reactants. Now, entropy of products. What is the stoichiometric coefficient of product? That is 1. 1 into entropy of X by 3. That is 50. So, this is entropy of products minus entropy of reactants. Go to this side. Stoichiometric coefficient 1 by 2 multiplied by. What is the entropy of X2? That is 60. Plus stoichiometric coefficient 3 by 2. What is the entropy of Y2? That's 40. Perfect. So, entropy change during the reaction will be equal. This is 50 minus. This will be 30. This will be 60. Right? So, this will be exactly how much? 90 and 50. This is minus 40 joules per Kelvin per mole. So, this is the delta S for the reaction. I got delta S. I was not given with delta S. I calculated delta S. I calculated delta S, right? Well, as per the question, I'm given with delta H as well. But delta H is in kilojoules. This value I got in joules. So, I can say minus 30 kilojoule means minus 30,000 joules. Correct? Now, we know temperature should be kept greater than delta H by delta S. What is delta H? Delta H is minus 30,000 divided by delta S is minus 40, right? Minus 40. Perfect. So, T should be greater than, I would say 750 Kelvin. Temperature should be greater than 750 Kelvin. Then only I would say temperature should be kept greater than 750 Kelvin. Then only I would say delta G would come out to be negative. And when delta G for the system is negative, that means the reaction is going to be spontaneous. Am I clear? Everyone in the chats? Everyone in the chats, people, quickly, quickly, quickly. Yeah? Perfect. Perfectly done. I believe this sort of a concept will be easily solved if it comes in the examination. Okay? So, if you get a reaction and if you get entropies of reactants and products, you'll be first of all calculating entropy change during the reaction, delta S. Once you calculate delta S, delta H will be given in the question, but delta H you have to take in joules, right? So, we can say for the process to be spontaneous, delta G should be negative. That means delta H minus T delta S should be negative. That means delta H should be less than T delta S. Or I can say T delta S should be greater than delta H. Or I can say T should be greater than delta S by delta S. Then only the reaction will be spontaneous, right? Right? Abdul, this is the continuation of that only. Don't worry. It is the continuation of that. Please don't spam. Okay? Please don't spam. I know what I'm doing. Don't worry. Okay. Chalo, I'm moving on, my dear students, to one more important concept. What is that? It is one small concept which is frequently touched in the examination. What is the concept? The concept is free expansion. The concept is free expansion. Okay. How do we define free expansion? It's a simple concept. Okay. Simple concept. There are no numericals here, but it's a simple concept. It can be asked. It can be asked. This concept was asked 3-4 years back. So there's a strong probability that it will be asked again this year. Have a look. How do we deal with this? What is free expansion, first of all? Free expansion is nothing but it is defined as expansion. Expansion of the system against zero external pressure. Or you can say it is defined as the expansion in vacuum. What does it mean? What does it mean? Try to understand, my dear students, what does it mean? First of all, imagine that this is your container. Imagine that this is the container. Over here, this container has got a piston. This is a piston, right? The piston can go out. It can come inwards as well. And imagine there is an ideal gas. There is ideal gas present in this container. There is ideal gas present in this container. This piston, it is a movable piston. It can go outwards. It can go inwards, right? Now, my dear students, on this piston, how many pressures will be acting? I will say these gas molecules, they'll be colliding with this piston. So in this particular direction, you will have pressure of gas. In this particular direction, you will have pressure of gas. Outside, there is atmosphere. Outside the piston, there is atmosphere. Atmosphere also contains gases. Those gases will be also colliding with this piston in this direction. So in this direction, it is going to be P external. In this direction, it's going to be P external, right? So on this piston, my dear students, there are two pressures acting. One is P gas, one is P external. Now the first thing. Understand, people. Now the first thing. If for example, P gas is equal to P external. If P gas and P external are equal, will the piston be moving? No, the piston will be still as such. If P gas and P external are equal, the piston will not move. Now, if suddenly P external becomes zero, if suddenly I create vacuum from outside, no atmosphere, that means P external zero. If suddenly P external becomes zero, this piston will abruptly go outwards. And when the piston abruptly goes outwards, what will happen to the volume of the vessel? What will happen to the volume of the container? If the P external abruptly becomes zero, the piston will abruptly go outwards. That means volume of the container will increase. If volume of the container increases, that means volume of the gas also increases because there's a gas in the container. If volume of the vessel increases, that means volume of the gas increases. An increase in the volume of the gas is what we call as expansion. Increase in the volume of the gas is what we call as expansion, right? So expansion is happening. Expansion of the gas is happening against zero external pressure. Expansion of the gas is happening against zero external pressure. Whenever you see expansion of the gas happening against zero external pressure in vacuum, we call this expansion as the free expansion. And my dear students, if P external is zero, you know W is equal to minus P external delta V. If P external is zero, that means W value is zero. So whenever you hear a term free expansion, remember W value is taken as zero. Whenever you hear a term free expansion, remember W value is taken as zero. I believe this is clear to everyone. Yeah. Now people, now comes here one thing. What is that? Have a look. This free expansion is basically of two types. One is called as isothermal free expansion. One is called as isothermal free expansion of an ideal gas, basically, okay? Isothermal free expansion of an ideal gas. The second will be adiabatic free expansion of an ideal gas. Second will be adiabatic free expansion of an ideal gas. Adiabatic free expansion of an ideal gas. Adiabatic free expansion of an ideal gas. Now, my dear students, try to understand very carefully what these are. First of all, the term mentioned here is free expansion. Whenever you hear a term free expansion, that means expansion is happening in vacuum. That means W value is zero. The process isothermal. Ideal gas is undergoing isothermal process. Remember, whenever ideal gas undergoes isothermal process, its delta U is also 0. Now, W is 0, delta U is 0. If I use first law of thermodynamics, first law says that delta U is equal to Q plus W. If delta U is 0, W is 0, that means Q is becoming 0. Q is equal to 0. Q is equal to 0. That means there is no heat exchange between system surroundings. That means the process which one? The process adiabatic. So can I generalize a simple statement? Can I say an isothermal free expansion, an isothermal free expansion of an ideal gas is adiabatic as well. Is adiabatic as well. This particular statement can be asked. Okay. Now people, adiabatic free expansion of ideal gas. Here the term mentioned is free expansion. That means free expansion means W is 0. Adiabatic means Q is 0. First law says that delta U is equal to Q plus W. Now Q is 0, W is 0, so delta U is 0. Delta U 0 means, what is delta U for ideal gas? I hope you know delta U for ideal gas is NCV delta T. So this term is equal to 0. Now this term can be only 0 if delta T is 0. Delta T can be 0 if temperature of the system, temperature of gas is constant. Temperature of the gas remains constant in isothermal process. So I can generalize one more statement. What is that? I can say an adiabatic free expansion, an adiabatic free expansion of an ideal gas. An adiabatic free expansion of an ideal gas is isothermal as well. Okay, these two statements are very important, so I would want you guys to remember it, right? Sir, I got a question from free expansion in today's JEE examination. That's great. That's great. Wonderful. Can you tell me, Arya, what was the question though? The question would have been something around these lines only. Yeah? The question would have been something around these lines only. Yes or no in the chats? Can you tell me quick? Quick. Okay, it was match the following, huh? Got it. So tell me once in the chats if this is clear. Can you quickly tell me once in the chats if this is clear? Quickly, my dear students. Every one of you. I want everyone to say it quickly so that we can move on to the next topic, guys. Okay, perfect. Chalo, I'm moving on to one more then. I'm moving on to one more concept. I'm moving on to one more simple concept. Have you heard about cyclic process? Have you heard about cyclic process? Well, in chemistry, you get simple questions based on cyclic processes. Let me show those cyclic processes to you. Let me tell you what kind of questions can be framed. First of all, cyclic process, what is that? Cyclic process is nothing that I would say whenever system returns to its initial state. Whenever system returns to its initial state after going through a lot of steps. Whenever a system returns to its initial state after going through a lot of steps. What does it mean? What does it mean? Have a look. For example, I am going to make a PV graph here. Let's say on this side I'm plotting pressure. On this side, I'm plotting volume. Try to understand. Let's say this point A is the initial state of the gas, at which the gas has got some pressure, the gas has got some volume as well. Now the gas is going from A to B. Now the gas is going from B to C. Then it's coming from C to A. Then it's coming from C to A. Do you see? The system is returning to its initial state after going through a lot of steps. Whenever system returns to its initial state after going through a lot of steps, we call this particular process the cyclic process. Whenever system returns to its initial state after going through a lot of steps, we call the process to be as, we call it as the cyclic process. Number one. My dear students, in case of the cyclic process, do you see initial state and final state are same? Initial state and final state are same. And let me tell you, if initial state and final state are same, you heard about state functions? State functions, they depend only on initial state and final state. State functions, they only depend on initial state and final state. If initial state and final state is same, that means the initial value of state function and the final value of state function will also be same. Right? Which means that change in the value of the state function for a cyclic process, change in the value of a state function for a cyclic process will be 0. Change in the value of the state function for a cyclic process will be 0. Now, my dear students, what all state functions we have? Internal energy, enthalpy, Gibbs free energy, etc. So I can say delta U. Internal energy is a state function. Delta U net for the cyclic process is equal to 0. This is the first point. Delta U net for the cyclic process is equal to 0. Similarly, delta H net for the cyclic process is equal to 0. Right? Now, my dear students, one important thing, try to understand. Delta U as per first law of thermodynamics is nothing but Q plus W. So delta U net can be written as Q net plus W net. So I would say Q net plus W net is equal to 0. Or I can say Q net is equal to minus times W net. Q net is equal to minus times W net. Q net is equal to minus times W net in case of cyclic process. Now people, this Q net. Now this Q net. How can we calculate this Q net? This Q net can be calculated as Q during the process AB plus Q during the process BC plus Q during the process CA. Heat absorbed or released during the process AB plus heat absorbed or released during the process BC plus heat absorbed or released during the process CA. Similarly, if I ask you to calculate W net, how do I calculate W net? Work done during the process AB plus work done during the process BC plus work done during the process CA. Right? At the same time, one more thing. Magnitude of W net. Magnitude of W net. How it can be calculated? There is one more way of calculating magnitude of W net. It is nothing but its area enclosed by the loop. It is area enclosed by the loop. So this is the loop here. Whatever is the area enclosed by the loop, that gives me the magnitude of net work done during the cyclic process. And remember, if the cycle is clockwise, in chemistry, take the W net sign as negative. And if the cycle is anti-clockwise, take the W net sign as positive in chemistry. Okay? In chemistry. Perfect. And my dear students, there is one more thing which I would want to share with you. What is that? Sometimes they'll ask you about the efficiency of the cyclic process. Sometimes they'll ask you about the efficiency of the cyclic process. And efficiency is equal to area enclosed divided by area under multiplied by 100. Now you must be thinking, what is area enclosed? What is area under? See, let's say this point A, this point B, this point C. For example, I'm calling this as point D and I'm calling this point as E. Right? Now area enclosed. Area enclosed means this particular area. Area enclosed by this particular curve. So I'm writing area of A, B, C, A. A, B, C, A. Right? Divided by area under. What is the area under this entire curve? This entire area. Right? It means that I'm talking about area of A, B, D, E, A. Area of A, B, D, E, A. Right? Multiplied by 100. This is the formula with the help of which you can calculate efficiency of the cyclic process. Simple. Simple, my dear students, right? For example, I'm giving you some basic questions so that you can understand and analyze all of this and try to utilize these in the questions. For example, you are getting a question like this. For example, a simple question you are getting like this. And in chemistry, you will get simple questions only. Let me be very honest. In chemistry, from cyclic process, you will be getting simple questions only. For example, I'm plotting a graph between pressure and volume. Okay, the graph is, for example, like this. It's a triangle, right angle triangle. Let this be point A, let this be point B, let this be point C, right? I'm showing the arrows in this direction. I'm showing the arrows in this direction, right? Let's say at this particular point, volume is 2 liters. Let's say at this particular point, volume is, for example, 10 liters, right? Let's say at this particular point, pressure is, for example, 2 atm. Perfect. Let's say at this particular point, pressure is, for example, 6 atm. Now, what all things I'm asking you? The first question which I'm asking you, calculate W net. The second thing I'm asking you, calculate Q net. The third thing I'm asking you, calculate the efficiency of this process. These are the 3 questions which I'm asking you. You should be in a position to give it a try. These are the 3 questions, people, which I'm asking you. If you look carefully, first of all, I need to calculate W net. So first of all, I will try to calculate magnitude of W net first, because magnitude of W net is area enclosed by the loop, right? It's a triangular one, and area of the triangle is half of base into height. Base is 2 liter to 10 liters, that's 8. Height is from here to here, 2 to 6, that's 4. So 8, 4, 32. 32 divided by 2 is 16. So W net is equal to 16 atm liter. It is magnitude of W net. Now, I need to write this W net with the sign. Tell me, is the cycle clockwise? Yes, the cycle is clockwise. Whenever cycle is clockwise, the sign of it is negative, right? So minus 16 atm liter. This is W net. Now we know already, in case of the cyclic process, Q net is equal to minus times W net. Few minutes back only I told you. Q net is equal to minus times W net, right? So I would say Q net value will be equal to minus times this. That means 16 atm liter. So you calculated Q net as well. If you calculate Q net as well, right, you can calculate efficiency as well. How do I calculate efficiency? Efficiency is going to be area enclosed. Area enclosed is how much? That is 16. Divided by area under. Area under means this complete area. So it becomes a trapezium. Area of trapezium is going to be half of sum of parallel sides. From here to here, it's 6. Plus from here to here, it's 2. Into distance between them, from 2 to 10. 2 to 10 means 8 multiplied by 100. Just solve this and get the efficiency of this particular cyclic process as well, right? Am I clear, guys? Is it clear to everyone? Is it clear? Did you understand how to deal with such kind of the questions? Okay, one question I'm giving you as the homework. Please and please do give it a try. For example, I'm giving you a cyclic process like this. Let's say this is pressure, this is volume, and here I'm plotting a circle. Okay. This is, for example, your 2 liters. This is 10 liters. This is 4 atm. Okay. This is 12 atm. The arrow is in this direction. Now the first question which I'm asking you, W net. Second question, Q net. And third question, efficiency. Will you be in a position to solve this question quickly? Right? Will you be able to solve this? I believe yes. I think yes. JEE Mains PYQ 2025 in my shift 23rd Jan. Was this the question asked? Would have been, because these sort of questions are asked. Okay? Dear students, I hope you would be in a position to solve this sort of a question. I'm moving on to one more concept. There are a lot of questions, my dear students, which are asked related to equivalent mass calculation. Have you heard? Equivalent mass calculation. Lot of questions are asked based on equivalent mass calculation. Let's try to understand. How do we do the equivalent mass calculation? See, I'm giving you one direct formula with the help of which you can calculate equivalent mass. Equivalent mass of the substance is nothing but it is molar mass of the substance divided by n factor of the substance. Molar mass of the substance divided by n factor. Molar mass, all of you know how to calculate. But how do we calculate n factor? That's the point. How do we calculate n factor? That's the point. See guys, first of all, what all n factors you need to remember? My dear students, important ones. That is n factor of an acid. How do we get, or leave acid aside? First of all, n factor of the salt. How do we get the n factor of salt? N factor of the salt is calculated as the total cationic or the total anionic charge. Total cationic or total anionic charge is something I'll be calling as n factor of the salt. For example, let's have a look. For example, see guys, for example, I'm taking a general salt as NaCl, correct? NaCl. The charge present on sodium is +1, the charge present on chlorine is -1. So total cationic charge here is +1. Total anionic charge is -1. So take the total cationic or total anionic charge. Total cationic charge is 1, right? So its n factor is 1. For example, you have got BaCl2. This 2 goes here, so it's +2. This 1 goes here, so it's -1. Calculate the total cationic charge. Total cationic charge is +2. So its n factor is 2, right? For example, you have got AlCl3. This 3 goes here. This 1 goes here. Calculate the total cationic charge. Total cationic charge is 3, right? So n factor is 3. For example, you have got Al2SO4 whole thrice. Al2SO4 whole thrice. This 3 goes here. This 2 goes here, right? Now, on one aluminum atom, the charge is +3. On 2 atoms, the charge is +6. So total cationic charge here is +6. Similarly, on 1 SO4, the charge is -2. On 3, it's be -6, right? On 1, it is -2. On 3, it will be -6. So total cationic +6. Total anionic is -6. Take either total cationic or total anionic. So this is the n factor. If you got the n factor of the salt, if you got the n factor of the salt, will you be able to calculate the equivalent mass of the salt? And I would say equivalent mass is nothing but that is molar mass divided by n factor, right? So this is the first thing which you need to know. Second, my dear students, what is that? That is n factor of acids. This is important. N factor of acids. N factor of acids is nothing but it is the basicity of the acid. How do we define basicity? There are many ways. Let me just discuss 2. Basicity of the acid is nothing but number of H positives and acid donates. Or I'll say number of OH negatives and acid accepts. For example, let me take one acid, HCl. One more acid, for example, H2SO4. One more acid, for example, H3PO4. One more acid, for example, HNO3, right? If you introduce this in water, it gives 1 H positive. If you introduce this in water, it is going to give 2 H positives. This will give 3 H positives. This will give 1 H positive. The number of H positives and acid donates. That defines its basicity. And whatever is the basicity, that's what you call as n factor. So here the n factor is 1. Here the n factor is 2. N factor of H3PO4 is 3. N factor of HNO3 is 1. If you got the n factors of all these acids, you can calculate their equivalent masses. How? Molar masses divided by n factor. Molar mass of HCl divided by n factor will give its equivalent mass. Right? Simple. Now guys, now. Tell me one thing. For example, I'm writing H3PO2. I'm writing H3PO3. I'm writing H3PO4. I'm writing H3PO5. H3PO5, right? Can you tell me how many H positives this should donate? It should donate 3 H positives. It should also donate 3 H positives. It should also donate 3. It should also donate 3. But the case is not that. Remember, an acid donates only that hydrogen. An acid donates only that hydrogen in the form of H positive. An acid donates only that hydrogen in the form of H positive, which is attached to more electronegative element like fluorine, oxygen, nitrogen. An acid donates only that hydrogen in the form of H positive, which is attached to more electronegative element like fluorine, oxygen or nitrogen. For example, if we talk about this H3PO2, if you look at its structure, it will look like this. Right? It will look like this. So there is only one hydrogen that's attached to more electronegative element like oxygen. So this acid is going to donate only this hydrogen. So its N factor is 1. Right? For example, H3PO3. H3PO3. This is your H3PO3. So this acid has got 2 hydrogens which are attached to more electronegative element like oxygen. So it's going to donate these 2 H positives. So its N factor is 2. Similarly, when you look at its structure, its N factor is 3. Similarly, its N factor is also 3. So these are the N factors. If you got their N factors, you can calculate their equivalent masses. How? Molar masses divided by N factors. Simple. Right? Right, people? I believe this is clear. Now, see what kind of questions are asked in your exam here. See what kind of the question can be asked in your exam. The question will be like this. You'll be given with a reaction H2SO4 plus NaOH, right? It gives NaHSO4, and with that you'll be given with water. They'll ask you calculate the equivalent mass of H2SO4 in this reaction. Calculate the equivalent mass of H2SO4 in this reaction. Similarly, they'll give you one more question like this. They'll give you H2SO4 plus 2 times NaOH. It gives Na2SO4 plus 2 times water. Okay, and they'll ask you again, calculate the equivalent mass of H2SO4 in this reaction as well. So 2 questions I'm giving you. My dear students, understand. Normally, if you use your brain a bit, this H2SO4 generally gives 2 H positives. So N factor should be 2 in both the reactions. But, try to understand. You must have heard somewhere when one H positive combines with one OH negative. When one H positive combines with one OH negative, what do we get? We get one water molecule. Similarly, when 2 H positives combine with 2 OH negatives, what do we get? We get 2 water molecules. Have you heard about this? Of course you would have. Tell me how many water molecules are formed here? 1. That means this acid would have given 1 H positive. This base would have given 1 OH negative. And this H positive OH negative would have combined and formed 1 water molecule. Right? So how many H positives this acid is giving? 1 H positive. The number of H positives an acid donates, that defines its N factor. So its N factor is 1 here. If N factor is 1, so its equivalent mass will be equal molar mass of H2SO4 divided by its N factor 1. Done? Done, people? Understood what I said? Similarly, how many water molecules are formed here? 2. 2 water molecules are formed. If 2 water molecules are getting formed, that means this acid will give 2 H positives. This base will give 2 OH negatives. And 2 H positives, 2 OH negatives will combine and form 2 water molecules. So this acid is donating 2 H positives, and the number of H positives an acid donates, that defines its N factor. So its N factor here will be 2. You got its N factor. So you can calculate its equivalent mass. Molar mass divided by N factor. Right? Now, if they ask you a question, is equivalent mass a fixed quantity or variable quantity? See, equivalent mass of H2SO4 here is 98 grams. Here it is 98 by 2 grams. Equivalent mass of the same substance is different in different reactions. Equivalent mass of the same substance is different in different reactions. So equivalent mass is a variable quantity, unlike molar mass. Molar mass is always fixed, but equivalent mass can change when you change the type of the reaction. Got it? Got it, people? Now one more thing. Sometimes they'll give you certain reactions like this, and they'll ask you to calculate the N factors. For example, let me take some simple reactions so that you can understand it properly. For example, I'm writing MnO4 negative gives Mn di positive. They'll ask you what is the N factor of a reactant here. For example, I'm writing Cr2O7 di negative gives Cr tri positive. Calculate the N factor of this, right? For example, they'll give you C2O4 di negative gives CO2. Calculate its N factor. Basically, why do I need N factor? I need N factor to calculate equivalent mass, right? Because equivalent mass is equal to molar mass by N factor, right? For example, sometimes they'll give a reaction like this. Let's say VO gives V2O5. Perfect. Calculate the N factor of reactant, right? Now, how do we get the N factors in such cases whenever you are given with the reactions like this? First of all, if I ask you what is the oxidation state of manganese here, when you calculate, it will be +7. Here it is +2. +7 to +2. What is the change? Final minus initial. The value is 5. 5 is the change for one atom. We have got only one atom of manganese, so its n factor is 5. Its n factor is 5, right? Sometimes they'll ask you what is the n factor of this product. If they ask you what is the n factor of this product, then you'll do the same thing in the reverse format. Then you'll call this as initial oxidation state. You'll call this as final. Final minus initial. Change is again 5. 5 is the change for 1. I have only 1 here. So 5 into 1 is 5. So its n factor is also 5. Do you understand? Hello? Hello? Are you listening to me? Guys, do you understand what I said? Did you just understand? Hello, hi. I'm here. I'm here. Okay. Let's have a look on few more things. If I ask you to calculate its n factor, to calculate the n factor, calculate its oxidation state first. What is the oxidation state of chromium here? What is the oxidation state of chromium here? Calculate it. This will be 2x. This will be minus 2. Into 7 is equal to minus 2. This will be plus 6. Here it will be plus 3. So my dear students, plus 6 to plus 3. What is the change? Final minus initial. The value comes out to be 3. I'm just taking magnitude, right? Final minus initial ka magnitude. That's 3. 3 is the change for 1 chromium. I have 2. So 3 2s are 6. Its n factor is 6. Right? What about this n factor? Go to the reverse format. This is initial. This is final. Final minus initial ka mod. That's 3. 3 is the change for 1. I have only 1 here. So its n factor is 3. Get the oxidation state of carbon. When you calculate this plus 3, this carbon will be in plus 4. So plus 3 to plus 4 changes. Plus 3 to plus 4 changes. Final minus initial. The value is 1. 1 is the change for 1. I have 2. So its n factor is 2. Its n factor is 2. Now, what about this one? Initial, final. Final minus initial mod. 1. 1 is the change for 1. I have only 1. So its n factor is 1. This is going to be your homework question. This is going to be your homework question. Now, guys, now, one more thing. Sometimes, there will be a compound like this. For example, ABC. This is a compound. So, if you look at these substances, I deliberately gave you those substances here in which oxidation state of only one element was changing. I deliberately gave you only those compounds here wherein oxidation state of only one element was changing. Now, what if there is a compound? There is a compound which is participating in some reaction and oxidation state of more than one element is changing. Right? What if there is a compound like this ABC? If this is participating in some reaction, what if oxidation state of more than one element will be changing in the reaction? How do we calculate its n factor at that time? My dear students, there is a solution to that as well. What is the solution? Have a look. For example, this ABC is a compound and it's participating in some reaction. Now, let's say there is the possibility the oxidation state of A as well as B during the reaction is changing. The oxidation state of A as well as B during the reaction is changing. Now, imagine oxidation state of A as well as B is increasing. This is one possibility. Oxidation state of A as well as B is decreasing. One more possibility. Oxidation state of A is increasing, B is decreasing, right? One more possibility. Oxidation state of all the three atoms is increasing. One more possibility. All the three atoms decreasing. One more possibility. Oxidation state of two atoms increasing, one decreasing. Oxidation state of two decreasing, one increasing. These are all the possibilities, all the permutation combinations I showed here. Right? Sir, we are from Unacademy, Coimbatore. Can you please visit us? I have visited you guys once. Right? Was that Coimbatore or Pondicherry? No, Coimbatore. I visited the Unacademy offline center once. Last year, I think. Yeah. Right? Surely, I'll try to come sometime. Pondicherry Center also I have visited when the center was launched. I was there as a guest, yes. So Hyderabad Center I have not. Basically, it's very far to travel. You know, I am from Kashmir. From Kashmir to Coimbatore, like it's from north to south. It takes entire day to travel basically. First of all, I have to take my flight from Srinagar to Delhi, from Delhi to Chennai, from Chennai to, Coimbatore, one more flight. So it's very, far basically. That's the reason. If it was like till Delhi, I would have been coming frequently. Session duration will be 2 hours. Okay, let's focus. Let's focus again. Okay, let's not lose the focus. Let's not lose the focus. Let's not lose the focus. Have a look now. What I'm trying to say is, for example, there's a compound ABC. Let's say this compound is participating in some reaction. Let's say during the reaction, these are all the possibilities which can happen. Oxidation state of A and B can increase. A and B both can decrease. One can increase, one can decrease. All the three can increase. Now, how do we calculate their n factors? The n factor of the first one will be simply n1 plus n2. The n factor of this one will be also n1 plus n2. Now, see, both in one direction, n1 plus n2. Both in one direction, n1 plus n2. One in upward, one in downward. So it's mod of n1 minus n2. So opposite direction means subtraction. Opposite direction means subtraction. Same direction means addition. See, same direction all the three. So it's n1 plus n2 plus n3. It's n factor, right? Same direction all the three. Again, n1 plus n2 plus n3, right? 2 in same direction, 1 in opposite direction. 2 in same direction means n1 plus n2. And 1 in opposite direction means minus n3, mod. 2 in same direction, so it's n1 plus n2. 1 in opposite direction, minus n3, a mod. This is how you calculate its n factor. Let me take one example as well. Let's take one example as well. Okay, let's take one example. Just one example, that's more than sufficient. For example, I'm writing something like this. FeC2O4, ferrous oxalate. It gives Fe tri-positive plus carbon dioxide. And I'm asking you to calculate the n factor of this particular species. I'm asking you to calculate the n factor of this particular species. Will you be able to do it? Absolutely, people. How exactly? Have a look. First of all, this is C2O4 dinegative. This is basically oxalate ion, C2O4 dinegative. If this is dinegative, that means iron has to be dipositive. That means iron has to be dipositive. Then only the species will be neutral. Right? Okay. Now, guys, if I ask you what is the oxidation state of carbon, you can calculate it. Plus 2 plus 2x minus 2 into 4 is equal to 0. This will be plus 3, right? This iron here is in plus 3 oxidation state. When you calculate for this carbon, this will be plus 4. Now, plus 2 to plus 3, increase in the oxidation state. Plus 2 to plus 3, increase in the oxidation state. Plus 3 to plus 4, again increase in the oxidation state. So can I say oxidation state of both the elements is simultaneously increasing? Oxidation state of this as well as this, both are increasing simultaneously, right? Now, how do I calculate its n factor? When oxidation state of two elements increase simultaneously, how do we calculate its n factor? It is going to be n1 plus n2. Its n factor is going to be simply n1 plus n2, right? What is n1 and what is n2? Have a look. Plus 2 to plus 3, plus 2 to plus 3, change is 1. 1 is the change for one atom, I have only 1. So n1 value is 1. Plus 3 to plus 4, the change is 1. 1 is the change for 1, I have 2. So n2 value is 2, right? So 2 plus 1 comes out to be 3. So its n factor is going to be 3. Do you understand? Yeah? Do you understand? Quick. Do you understand, people? Everyone? Yeah? Okay, all right. Let me give you one more question. One more question of the similar pattern. Let me see whether you'll be able to solve this or not. For example, the question is K4 Fe CN6. It gives Fe tri positive plus NO3 negative plus CO2. Okay. I am asking you to calculate the equivalent mass of this substance. I'm asking you to calculate equivalent mass of this substance. And I'm assuming its molar mass is M. Its molar mass is M. I have to calculate its equivalent mass. Equivalent mass will be molar mass divided by N factor. Equivalent mass will be molar mass divided by N factor. Molar mass is M. Now we have to calculate its N factor. How do I get its N factor? Now have a look. First of all, calculate the oxidation state of this iron. I hope you know how to do it. In coordination chemistry, you would have studied. This is plus 1 into 4. This is X. This is Cn negative basically. Minus 1 into 6 is equal to 0. So this will be plus 2. Right? This is technically Cn negative. This is technically Cn negative. In Cn negative, carbon will be in which oxidation state? X. Minus 3 is equal to minus 1. X will be plus 2. So in Cn negative, carbon is in plus 2 oxidation state. Nitrogen, its most common oxidation state is minus 3. Iron, here is in plus 3 oxidation state. When you calculate for nitrogen, X minus 6 is equal to minus 1, so plus 5. Right? Carbon here is in plus 4 oxidation state. Now look carefully. Look carefully what I say. Look carefully. See, iron is going from plus 2 to plus 3. Increase. Number 1. Carbon is going from plus 2 to plus 4. Again increase. Right? Nitrogen is going from minus 3 to plus 5. Again increase. So oxidation state of all the 3 elements is increasing. Oxidation state of all the 3 elements is increasing. Oxidation state of all the 3 elements is increasing. So how do I calculate this N factor? N1 plus N2 plus N3. N1 plus N2 plus N3. So my dear students, plus 2 to plus 3. Change is 1. 1 is the change for 1 iron. I have only 1. So N1 value is 1. Number 1. Plus 2 to plus 4. Plus 2 to plus 4. Change is 2. 2 is the change for 1 carbon. I have 6. So 2 6 are 12. So N2 value is 12. Right? Minus 3 to plus 5. Minus 3 to plus 5. What is the change? Final minus initial. So 5 minus minus 3. That will be 8. 8 is the change for 1 nitrogen. I have 6. So 8 6 are 48. So N3 is 48. Oh my God. N1 plus N2 plus N3. It will be 61. So N factor of this particular species. N factor of this particular species will be how much? N factor of this particular species will be 61. N1 plus N2 plus N3. So its equivalent mass will be equal to molar mass divided by 61. Yeah? Got this concept as well? And if you got this concept, guys, there is one more concept that I want to discuss with you. That is N factor in case of disproportionation. This is frequently touched. N factor in case of disproportionation. N factor in case of disproportionation. First of all, you should be knowing. I mean, you should know first of all what is disproportionation. Yeah? Okay, you should be first of all knowing what is a disproportionation reaction. Have a look what happens in disproportionation. Try to understand. For example, you have got a reaction like this. A2 gives A positive plus A negative. A2 gives A positive plus A negative. A2 gives A positive plus A negative. Now, my dear students, oxidation state of A here is 0. Here A is in plus 1 oxidation state. Here is A is in minus 1 oxidation state. Now 0 to plus 1 increase, 0 to minus 1 decrease. Can I say oxidation state of same element is increasing as well as decreasing? Oxidation state of same element is increasing as well as decreasing. So I would say this particular species undergoes disproportionation. So in disproportionation, what happens? In disproportionation, what happens? Oxidation state of same element increases as well as decreases simultaneously. And how do we get its N factor? Its N factor is calculated like this. N1, N2 divided by N1 plus N2. N1, N2 divided by N1 plus N2. Now, 0 to plus 1. What is the change? Final minus initial. The value is 1. What is the change for 1? I have 2. So N1 value is 2. N1 value is 2. 0 to minus 1. What is the change? Final minus initial. The value is 1. 1 is the change for 1. I have 2. So N2 value is 2. I got N1, I got N2. So N1 into N2 divided by N1 plus N2. The value comes out to be 1. So N factor of this A2 is equal to 1. N factor of A2 is equal to 1. Okay? Is it clear, guys? Is it clear? Is it clear? Now, for example, there was a question asked in JEE mains long back like this. Br2, it gives Br negative plus BrO3 negative, right? And they had asked you to calculate equivalent mass of Br2, right? They had asked you to calculate equivalent mass of Br2, and they had given the molar mass of Br2 as M. We were supposed to calculate equivalent mass of Br2. So equivalent mass of Br2 will be molar mass of Br2 divided by n factor of Br2. Now, I have to calculate the n factor of Br2 first. I have to calculate n factor of Br2. How exactly? How exactly? Have a look. Have a look. Try to understand. Same concept. Oxidation state here, 0. Here, -1. Bromine, +5. So 0 to -1, decrease. 0 to +5, increase. Oxidation state of same element is increasing as well as decreasing simultaneously. Oxidation state of same element is increasing as well as decreasing simultaneously. So this Br2 is undergoing disproportionation here. If it is undergoing disproportionation, how do I calculate its n factor? Its n factor is going to be n1, n2 divided by n1 plus n2. Now, get the value of n1 and n2. 0 to -1. 0 to -1. Change. Final minus initial. The value is 1. 1 is the change for one atom. I have 2. n1 value is 2. Okay. 0 to +5. What is the change? Final minus initial. The value is 5. 5 is the change for one atom. I have 2. So 5 2 is 10. So n2 value is 10. Right? So it's going to be 2 multiplied by 10 divided by 2 plus 10. The value comes out to be 5 by 3. Right? So n factor of Br2 is 5 by 3. So it's 5 by 3 here. The answer is going to be 3m divided by 5. This is the equivalent mass of Br2 in this reaction. Got it? Got it, got it, got it. Got it, people? Say yes or no in the chats. Everyone. Everyone means everyone. Okay, I'm giving you one more question here. I am giving you one more question here. For example, you have got the reaction like this. Okay, this is your homework question. H2O2 gives H2O plus O2. I am asking you to calculate equivalent mass of H2O2, which will be molar mass of H2O2. That will be 34 divided by n factor of H2O2. So technically, what do I have to calculate? Technically, I have to calculate n factor of H2O2. Technically, I have to calculate n factor of H2O2. Right? Technically, I have to calculate n factor of H2O2. So will we be able to calculate n factor of H2O2? Say it in the chats. Sir, I'm doing your Game of NEET 2.0 lecture in 2x. You can consult those lectures as well. They are very detailed, right? Whatever is you feel convenient for you, go for it. See, there is everything available on this channel. If you go to the playlist, all the chapters of physics, chemistry, biology will be there in one shot. One shot means one chapter in 8, 9 hours, 10 hours, 12 hours. So you can watch. I mean, everything will be there on the channel. Should I show it to you? Should I show it to you? For example, it will take me just a second. For example, this is your channel, right? Unacademy Indian English. What you have to do is go to the playlist. When you go to the playlist, automatically there will be a lot of playlists which you will be finding. So here it is Game of NEET 3.0. But here there are only 34 videos. 34 videos. That means there will be only almost like 30 chapters. So you can cover 30 chapters from here. Number 1. Number 2. Game of NEET 2.0. 80 lesson, 80 videos. 80 video means 80 chapters. And this is the most viewed playlist of this particular channel. Most viewed. Perfect. All the chapters will be there. So 30 from one playlist, 80 from another playlist, right? So everything is here. Okay, if you don't want to do this, if you want to do something different, you can do that too. What is that exactly? Just a second. Let me show that to you as well. One more thing. See, when you open the NEET English channel, when you go to the playlists, you'll find one more playlist like this. Do you see this? Bounce Back series, NEET 2025. In this particular series, I have completed sessions like complete class 11th physical chemistry in one shot, complete class 12th physical chemistry in one shot, complete class 11th organic in one shot, something like that, right? But in this playlist, you won't find the organic one, or I think organic will be there, right? Similarly, these are the marathons basically. All the other playlists are small playlists, like one chapter in like 2 hours, 3 hours, something like that. So everything is here on the channel. You just need to sit and watch. And at the same time, if you want to have a look on the organic chemistry classes, right? Your KK sir is doing amazing here on this channel, right? You can see his sessions, right? He has taken amines, aldehydes, ketones, carboxylic acids, alcohols, phenols, ethers, haloalkanes, arenes he has taken, right? Similarly, hydrocarbons he is done with, GOC is done with. So, and everything is here. Everything is here. It is just, you need to sit and do things. Okay? And if you want shortcut towards success, then the series which I'm currently doing, follow it. These top 50 concept series. Okay? Right? Chalo, let's move on. So I was asking you to calculate the equivalent mass of this H2O2. That means you need to calculate its N factor. You need to calculate its N factor. First of all, if you look carefully, guys, hydrogen peroxide, what is the oxidation state of oxygen in hydrogen peroxide? It's -1. Here it will be -2. Here it will be 0. -1 to -2, decrease. -1 to 0, increase. Oxidation state of same element is decreasing as well as increasing. So this particular species is undergoing disproportionation. If it is undergoing disproportionation, how do I calculate its N factor? N1, N2 divided by N1 plus N2. So its N factor will be N1, N2 divided by N1 plus N2. Now, -1 to -2, -1 to -2, change is 1. 1 is the change for 1, I have 2. So N1 value is 2, right? -1 to 0, what is the change? 1. 1 is the change for 1, I have 2. So N2 value is 2. So it's going to be 2 into 2 divided by 2 plus 2. Perfect. The value is 1. So N factor is 1. So the value will be 34 divided by 1 grams. So equivalent mass of H2O2 will be 34 grams only. Okay? Perfect. Am I clear with this? Did you understand how do we deal with such kind of things? Did you understand, guys? Every one of you? Am I like very, very, very clear to you? Perfect. All right. All right, guys. All right. There is one more very important topic, guys, from the chapter Kinetics. What is that? This concept is frequently again asked. This is frequently asked in your JEE examination from past 2-3 years. So it can be asked in your NEET as well. There is a strong probability. There is a strong probability, right? So what is this concept exactly? It is calculation of order from half-life. Calculation of order from half-life. Just give me a second. Just give me a second. Just a second, guys. Okay. Calculation of order from half-life. This is again one very, very, very important concept. Why it's important? Have a look. My dear students, let's say you have got the reaction A gives B. This is the reaction. A gives B. Its order can be anything. 0, 1, 2, 3, whatever. I'm assuming its order is equal to N. Order of this reaction is equal to N. Order of this reaction is equal to N, right? Let me tell you, half-life of the reaction, T1 by 2, T 50%, half-life. I hope you know half-life, what half-life is. Time taken to complete 50% of the reaction. Time taken to complete 50% of the reaction is called as half-life. Half-life of the reaction is directly proportional to, let me tell you, half-life of the reaction is directly proportional to initial amount of reactant raised power 1 minus n. This is one direct result which I'm giving you. Half-life of the reaction is nothing but it's directly proportional to initial amount, which can be initial moles, initial concentration, or initial pressure. This can be moles, concentration, pressure, right? I'm telling you, half-life of the reaction is directly proportional to the initial amount of reactant raised power 1 minus n, where n represents order of the reaction. Try to understand, guys, what I'm going to do. If I remove the proportionality sign, I'll be getting a constant K. A raised power 1 minus n. Okay? Raised power 1 minus n. Perfect? Right? Now, from this, I'm going to get one more equation. And that equation I'll be using in the questions. The equation is T half 1 divided by T half 2. T half 1 divided by T half 2 is equal to A1 divided by A2 whole raised power 1 minus n. This is the equation from which you get frequently the questions. This is the equation. I'll show you its application. I'll show you how it's used. Just give me some time. I'll show you how it's used. Okay, I'll show you how it's used. So first of all, what is this A? A is the initial amount of reactant. So let me write this A over here. This A is nothing but it is the initial amount of kya? Of reactant. That means it can be initial moles of reactant, initial concentration of reactant, or even initial pressure of reactant. Okay, point number 1. Point number 2, guys, if you look at this particular equation, multiply with the log for this particular equation. What do I get? I get a log of T half is equal to, this is log of m into n. Log m into n is going to be log of m plus log of a raised power 1 minus n. 1 minus n comes to the front, it's log of a. This is the logarithmic form of the same equation. Now, if this is the logarithmic form of the same equation, that means we can plot a graph here. The graph is going to be between log of T half versus log of a. Log of T half versus log of a. Log of T half you are plotting along y-axis. Log of a you are plotting along x-axis. So this becomes your m. This becomes your c. Sign here is plus. This equal. Y is equal to mx plus c. Straight line. Y is equal to mx plus c. Straight line. What about its slope? Slope means the value of m. M value, as you can see, it's 1 minus n. Okay. And what about the intercept? Intercept means distance from here to here. Intercept is denoted by c. C is nothing but log of k. Okay. Okay. Now the point is, where do we use this equation? What kind of questions can be framed? Now people, have a look what kind of questions can be framed. First of all, I hope you got the equations. Half-life of the reaction is directly proportional to the initial amount of reactant raised power 1 minus n. So I can say T half 1 divided by T half 2 is equal to A1 divided by A2 raised power 1 minus n. Okay? Now, try to understand people. Try to understand. For example, I'm giving you a question like this. A simple question I'm giving you. My dear students, you are given the reaction A gives B. This is the reaction, okay? The question is, calculate order of the reaction. And you are given the graph. The graph is again the same. Log of T half versus log of A. And the graph is given like this. And this angle is given to me as 135. Don't you think we'll be able to solve this question in like seconds? Don't you think, people? So first of all, the graph is between log T half versus log A. Few minutes back I told you its slope. Its slope is nothing but 1 minus n. Right? Slope is what? Tan of theta. Theta is this external angle basically, 135. Tan 135 is minus 1. So I would say 1 minus n is equal to minus 1. So that means n is equal to 2. And what was n? N represents order of the reaction. N represents order of the reaction. Nothing else. Right? N represents order of the reaction. For example, giving you one more question. Look at this format. This format is also frequently asked. Reaction is A gives B. The question is calculate order. And you are given with the table. Table is something like this. Here they are mentioning concentration of A. Here they are mentioning half-life. And in the table, the data is something like this. When the initial concentration of A is 50 molar, at that time half-life of the reaction was 4 seconds. When the initial concentration of reactant was 100 molar, at that point of time half-life of the reaction was 2 seconds. When the initial concentration of reactant is 200 molar, at that point of time half-life of the reaction is 1 second. Calculate the order of the reaction. So, what do you think? Are we going to solve this question easily? What do you think? What do you think, guys? So first of all, the reaction is given as A gives B. When the initial concentration of reactant was 50 molar, at that time half-life of the reaction was 4 seconds. When the initial concentration of reactant was 100 molar, half-life of the reaction was 2 seconds. When the initial concentration of reactant was 200 molar, half-life of the reaction was 1 second. They are asking us to calculate order. Order means n value. Order means n. What I'll be doing, out of all the 3 columns, let me select 2 columns of my choice. I've selected 2 columns of my choice, right? So let me call this as T half 1. This will be T half 2. This will be A1. This will be A2. We already know the result. The result is in front of us. T half 1 divided by T half 2 is equal to A1 divided by A2 whole raised power 1 minus n. So what is T half 1? T half 1 is 4 seconds divided by T half 2, that is 2 seconds. A1 is 50 molar. A2 is 100 whole raised power 1 minus n. So this value is 2. This value is 1 by 2 raised power 1 minus n. So 2 is equal to 2 raised power n minus 1. So I would say n minus 1 value is equal to 1. N value is equal to 2. N value is equal to 2. Okay, and what is n here? N represents the order of the reaction. Got it? Is it clear? Is it clear? This sort of a question is frequently asked. By the way, in the question, I gave you the concentrations. Instead of concentrations, they can give you pressures as well. They can give you pressures as well. They can give you pressures as well, right? They can give you pressures as well. So again, you have to use the same equation, right? I hope this is also clear to everyone. I hope this is also clear to everyone. Now, guys, just a second. Just a second. Okay. This is your one more question frequently asked, guys. This is your one more question frequently asked. Sir, do one pressure related. Instead of concentrations, they'll give pressures. For example, 50 mm of Hg, 100 mm of Hg. So 50 mm of Hg will be A1, 100 mm of Hg will be A2, for example. Nothing else. Sir, will you complete all the top? Of course, I'm going to complete all the topics. I've told you already, right? Maybe not in the today's session, in one more session. Like slowly we are doing. We have got time left, don't worry. There are a lot of things which are planned on this channel. Next class, I'll be taking day after tomorrow. Timing will be same. Okay. All right. Look here now. Experimental determination of order. How do we calculate order experimentally? My dear students, this is again one very important concept which is frequently asked. And how do we deal with this sort of equation? Understand. This is the simplest among all. Okay, simplest among all. You will be given with a reaction like this. There will be some experimental data given like this. As you can see, there are 3 experiments which are carried out. Concentration of Cl2 was kept this one. Concentration of NO was kept this one. Rate of the reaction was seen as this one. Similarly, second experiment, third experiment. 3 experiments were done for this particular reaction. So the question is saying, look at the data and find the order of the reaction. How do we deal with such kind of the questions? My dear students, your first thing always should be to write the rate law for the given reaction. And how do we write the rate law? Understand. R is equal to, R stands for rate of reaction, is equal to, K is the rate constant. Start with reactants. Concentration of NO. And here you will write raised power X. Concentration of Cl2, raised power Y. X is called as order with respect to NO. Y is called as order with respect to Cl2. And if I do X plus Y, that's called as overall order of the reaction. You know it. X plus Y is called as overall order of the reaction. Right? Now, how do we get this X? How do we get this Y? Simple. Do one thing. You wrote the rate law, right? put the first experiment data in this equation. When you put the first experiment data in this equation, your R value in the first experiment is 1 into 10 raised power minus 3. Your R value in the first experiment is 1 into 10 raised power minus 3 is equal to K. What is the concentration of NO in the first experiment? It is 0.05 raised power X. What is the concentration of Cl2 in the first experiment? It is 0.05 raised power Y. Correct? I'm calling this equation number 1. I'm calling this equation number 1. Now, put the second experiment data in the same equation. What is the value of R in the second experiment? It is 3 into 10 raised power minus 3. R is 3 into 10 raised power minus 3 is equal to K, I'm writing as such. What is the concentration of NO in the second experiment? Concentration of NO in the second experiment is 0.05. So it is 0.05 and here it's raised power X. What is the concentration of Cl2 in the same experiment? That is 0.15 raised power Y. Calling this equation number 2. Calling this as equation number 2. Now, my dear students, put the third experiment data in the same equation, right? See, look at this particular data. R value is how much? R value in the third experiment is 9 into 10 raised power minus 3 is equal to K. What is concentration of NO here? That is 0.15. 0.15 raised power X. What is the concentration of Cl2 here? That is 0.05 raised power Y. So this is equation number 3. So how many equations I got? Got 3 equations. I got 3 equations, right? Now, just divide these equations. Just divide these equations. What I'm trying to say, for example, I'm dividing equation 2 with equation 1. I'm dividing equation 2 with equation 1. So 10 power minus 3, 10 power minus 3 cancels out. 3 divided by 1 is 3 is equal. K and K cancels out. This term cancels out. 0.15 divided by 0.05. It will be 3 raised power Y. So when can be 3 raised power Y equal to 3? It is only possible when Y value is equal to 1. So I got Y, right? Now, do one more thing. What exactly? So do one thing. Equation 3 divided by equation 2. Equation 3 divided by equation 2. Equation 3 divided by equation 2. 10 power minus 3, 10 power minus 3 cancel. 9 divided by 3 is 3 is equal. K and K cancel. This term, no. Don't do 3 by 2. Just do one thing, 3 by 1. 3 by 1. Because when we do 3 by 2, nothing gets cancelled out. Our main motto should be something should get cancelled out. So 3 divided by 1. 9 divided by 1 is 9 is equal. This 10 power minus 3 cancels. K and K cancels out. This term cancel out. 0.15 divided by 0.05. That is 3. 3 raised power X. So 3 raised power X is equal to 9, which means that X has to be equal to 2. So you got X, you got Y. So I would say overall order of the reaction is equal to X plus Y, 2 plus 1, that is 3. Right? Again, simple. Got it? Now, can you give this question a try on your own? Should this be your homework question? This should be your homework question, guys. Right? This should be your homework question. Just tell me in the chats, will you be able to solve this on your own? So what you have to do is write the rate law for this reaction. Right? Get 3 equations by putting the data in the rate law. Get 3 equations. Divide the 2, divide the 2, divide the 2. Right? You'll get it. Anusha, you can just drag the video a little back. It'll be a replay for you. Why do you want me to repeat again? Just drag the video a little back. It'll be a replay for you, yeah? Put common sense to be used. Right? Got it, people? I believe I'm clear with this. And if I'm clear with this, there is something called as, there is a concept, a small concept, right, which is also asked. Okay, let's have a look on this particular concept as well. Rate of reaction. First of all, my dear students, let's say I'm writing the reaction N1A plus N2B. For example, it gives N3C plus N4D. Imagine it's a balanced chemical equation. This N1, N2, N3, N4, these are the stoichiometric coefficients. These are the stoichiometric coefficients of reactants and products, right? First of all, this A and B are reactants. And reactants, you know, they disappear with time. They get consumed with time. Your products, they appear with time. They get formed with time. Okay? So, my dear students, the first terminology which I'm using, that is a rate of disappearance. Rate of disappearance. Of what? Disappearance is a term which is used for reactants. For example, I want to know the rate of disappearance of A. Rate of disappearance of A. How do I write it? Rate of disappearance of A. How do I write it? Since I'm using the term disappearance, I'll start with the minus sign. Then I'll write change in the concentration of A divided by time interval delta T. This term is called as rate of disappearance of A. For example, I'm asking you to write rate of disappearance of B. B, rate of disappearance. Disappearance means minus sign. Change in the concentration of B divided by time interval delta T. Right? For example, I'm asking you to write rate of appearance. Rate of appearance of what? Rate of appearance of, for example, C. Since I'm talking about appearance, so I'll start with plus sign. Right? I'll start with plus sign. Then I'll write change in the concentration of C divided by time interval delta T. Similarly, if I write rate of appearance of what? Of D, it will be plus change in the concentration of D divided by time interval delta T. So this is how you write rate of appearance and rate of disappearance. When you write rate of disappearance, start with minus sign. When you write rate of appearance, start with the plus sign. Right? Now, there is one more term. What is that? That is rate of the reaction. Till now, I was talking about rate of what? Till now, I was talking about rate of disappearance of a reactant or rate of appearance of a product. Now, there is one more term, that is rate of reaction. How do you calculate rate of reaction? How do you write rate of reaction? Rate of reaction is nothing but it is defined as rate of disappearance or appearance. Rate of disappearance or appearance of reactant or product divided by stoichiometric coefficient of reactant or product. Rate of disappearance or appearance of a reactant or product divided by stoichiometric coefficient of reactant or product. What does that mean? See, rate of reaction is equal to, for example, I want to calculate rate of reaction with respect to A. A is a reactant. So I'll write rate of disappearance of A. Rate of disappearance of A, how to be written? Minus delta E by delta T divided by stoichiometric coefficient of A. Stoichiometric coefficient of A is N1. So finally I can write it as minus 1 upon N1 change in the concentration of A divided by time interval delta T. This term is going to give you the rate of the reaction with respect to A. You can calculate rate of the reaction with respect to B as well. With respect to B, B is again the reactant. So start with minus 1 divided by stoichiometric coefficient of B is N2. Change in the concentration of B divided by time interval delta T. This term also gives you the rate of the reaction in terms of B. You can calculate rate of reaction in terms of C as well. Then C is the product. So start with plus sign. 1 divided by stoichiometric coefficient N3. That and change in the concentration of C divided by time interval delta T. And you can calculate rate of reaction with respect to D as well. So plus 1 upon N4 change in the concentration of D divided by time interval delta T. So all these terms are going to give you what? All these terms will give you the rate of the reaction. Okay. Now, what kind of questions can be framed here? Simple questions, guys. Simple, simple, simple. Have a look. Look at this question. If the rate of appearance of O2, first of all, rate of appearance of O2, rate of appearance of what? O2. How do I mathematically denote it? Rate of appearance plus delta O2 by delta T. This is called as rate of appearance. When we write rate of appearance, we don't have to divide with stoichiometric coefficient. But when we write rate of reaction, we have to divide with stoichiometric coefficient. Matlab? Here I wrote disappearance, disappearance, appearance, appearance. I did not divide with stoichiometric coefficient. But when I wrote rate of reaction, I divided with stoichiometric coefficient everywhere. Be careful with that. Okay. So what I'm trying to say is, rate of appearance of O2 is given to me. That means delta O2 by delta T is given how much? 0.5 moles per liter per second. What am I supposed to calculate? I am supposed to calculate rate of disappearance. Rate of disappearance of what? Of N2O5. How do I mathematically denote it? Rate of disappearance of N2O5. Disappearance means start with minus. Then change in the concentration of N2O5 divided by delta T. I want to calculate this value. I want to calculate this value. Now people, how do I solve this? First of all, few minutes back I told you. Can I write rate of reaction with respect to N2O5? Yes. Minus 1 divided by 2. Minus 1 divided by 2. Change in the concentration of N2O5 divided by delta T. This is the rate of reaction with respect to N2O5. What is the rate of reaction with respect to O2? It is plus. O2 is product plus 1 divided by 1. Change in the concentration of O2 divided by time interval delta T. Correct? Right? Now, my dear students, this delta O2 by delta T is given to me in the question. That is 0.5. That is 0.5. If I take this 2 here, 2 into 0.5 becomes 1. So minus times delta of N2O5 divided by delta T is equal to 2 into 0.5. It becomes 1 mole per liter per second. Correct? This minus delta N2O5 by delta T is called as the rate of disappearance of N2O5. So technically, I calculated the rate of disappearance of N2O5, right? This is something I was supposed to calculate. Got it? Got it, guys? Am I clear? Say it once. Got it? Let's solve one more question. The question can be something like this. First of all, a graph between concentration versus time is given. And do you see with time concentration is decreasing? With time concentration, do you see it's decreasing? Concentration of what decrease with time? Concentration of what decrease with time? Concentration of reactant decrease with time. Reactant here is NH3. So this is the graph which is basically for NH3. It's the graph for NH3 basically. Because I saw with time concentration is decreasing. And we know with time concentration of reactant decrease. Right? So this is the graph for NH3. What do I have to calculate? Calculate the rate of the reaction in the interval 5 to 15 seconds. Calculate the rate of the reaction in the interval 5 to 15 seconds. So this interval delta T, which will be T2 minus T1, 10 seconds. So in this time interval, I have to calculate rate of reaction. Okay. Now, if you look at this particular one, I can say rate of the reaction is equal. What is the rate of reaction with respect to NH3? I'll start with minus because NH3 is reactant. 1 divided by stoichiometric coefficient is 2. Change in the concentration of NH3 divided by time interval delta T. This particular term gives me the rate of reaction. Right? So I'll start with minus 1 divided by 2. Change in the concentration of NH3. See, initial concentration of NH3 is 0.6. Final concentration of NH3 is 0.2. So final minus initial. Final minus initial divided by time interval 10 seconds. This will be 0.02 moles per liter per second. So this is the rate of the reaction which I was supposed to calculate. Simple. This is the rate of the reaction which I was supposed to calculate. Similarly, guys, similarly, look at this question. This sort of a question can be also asked here. You're given the reaction, some data is given like this, looks something difficult, some khatarnak data is given, right? Khatarnak data isko kehte hain. This is called as khatarnak data, right? It looks very dangerous, but it's very simple. What do we have to calculate? We need to calculate the relation between K1, K2, K3. Yeah? See how I'm going to deal with this. First of all, what is the rate of reaction with respect to N2O5? I'll start with minus 1 divided by stoichiometric coefficient is 1. Then I'll write change in the concentration of N2O5. You can use delta or D. Matlab, it's going to be D of N2O5 divided by dt. Or you can use delta as well. Since in the question they have given the D data, D. That's why I'm writing D here. Similarly, rate of reaction with respect to NO2. Start with plus 1 divided by stoichiometric coefficient 2. Change in the concentration of NO2 divided by time interval dt. Similarly, plus 1 divided by stoichiometric coefficient 1 by 2. 1 by 1 by 2 is 2. 1 by 1 by 2 is 2. So it's 2 times, right? Change in the concentration of O2 divided by time interval dt. Correct? Now, this particular term is given in the question. Look at this term. It is given in the question how much? It is given as K1 into concentration of N2O5, right? Is equal to 1 by 2. This particular term is also given how much? K2 into concentration of N2O5, right? Is equal to 2 times d of O2 by dt. It is K3 multiplied by concentration of N2O5. N2O5 cancel. K1 is equal to K2 divided by 2 is equal to 2 times K3. If I multiply throughout with 2, it becomes 2 times K1. This becomes K2 because 2 gets cancelled. It becomes 4 times K3. So this is the relation between K1, K2 and K3 over here. Is this particular concept also clear? So these sort of questions can be also asked. Right? I'm giving you one more question. My personal favorite, which has been frequently asked in JEE mains from last 3-4 years. So there is probability that it can be asked in your NEET as well. See, the question is like this. The question is you are given the reaction XA gives YB. XA gives YB. Okay, this is the reaction. XA gives YB. Now, as per the question, they have mentioned something like this. Given that log of minus dA divided by dt is equal to log of d of B divided by dt plus 0.3. This is the data that's given to me. Now, as per the question, they are asking me to calculate x and y. They're asking me to calculate x and y. So, can we solve these sort of questions? Can we give them a try? We can. We can. How exactly? See. First of all, rate of reaction with respect to A. I'll start with minus because A is the reactant. 1 divided by stoichiometric coefficient is x, right? It's going to be change in the concentration of A divided by time interval dt. Similarly, rate of reaction with respect to B plus 1 divided by y, change in the concentration of B divided by time interval dt. Okay, so I wrote the rate of reaction with respect to A as well as with respect to B. Now, do you look at these terms? This is in terms of log, this is in terms of log. This can be also converted in terms of log as well. If we are able to convert this in logarithmic form, then this can be simplified a bit. Instead of this 0.3, I can write log 2. You must be knowing log 2 is 0.3. You must be knowing log 2 is 0.3, right? Now, guys, have a look. It's going to be log of minus dA divided by dt is equal to log of m plus log of n is nothing but log of m into n, right? So it's 2 multiplied by dv by dt. If I take anti-log on both the sides, it's going to be minus dA divided by dt is equal to 2 times d of b divided by dt. If I take 2 here in the denominator, it will be minus 1 by 2 d of a divided by dt is equal to d of b divided by dt. Now, my dear students, I got 2 equations. Equation number 1, equation number 2. So compare these 2 equations. Just compare these 2 equations. My dear students, when you compare these 2 equations, this x here comes out to be 2, right? This is 1 by y. This will be 1 by 1. So y here will be equal to 1. Understood? So basically this was dA by dt. This is my dA by dt. Minus 1 by x, minus 1 by 2. So x is equal to 2. dB by dt, dB by dt. This is 1 by y, this is 1 by 1. So y value here is 1. So comparing x and y, x we got as 2, y we got as 1. Right? Am I clear? Am I clear, people? Quickly let me know in the chats if I'm clear to everyone. Quickly let me know in the chats if I'm clear to everyone. Right? Dear students, whatever concepts I discussed till now, all these will be asked in the NEET 2026 for sure. I'm telling you. Okay? Well, I'm not done yet. There are more concepts which are to be discussed, but I'll be discussing those concepts in the upcoming session. The session will be day after tomorrow. Day after tomorrow is what date? Today is Monday, Tuesday, Wednesday. So Wednesday at 9 p.m. there will be one more session of mine. Okay? That will be next session. All right? And the handwritten PDF of this particular session I'll be sharing on my Telegram. The Telegram channel name is Wassim Bhat Chemistry Official. Wassim Bhat Chemistry Official. This is the name of the Telegram channel. All right. Yes, KK sir is continuing. He is doing the organic part. He is doing the organic part. You need not to worry about it. You need not to worry about your organic part. So one more session I'll be taking day after tomorrow. Huh? Perfect. Chalo, I'll be taking a leave. One thing I would want, your comments on this particular video. When I end this video, please and please do write a comment whether you find this particular series very, very beneficial. Yes, I would want every one of you to let me know in the chats. I mean to let me know in the comments, not in the chats. All right? Chalo. Take care. God bless you all and love you all, guys. Bye-bye. God bless you.